All right, here is the answers to 8-7 practice. Sorry, I missed that on my last video recording. All right, this session we're going to talk about 5-8, investing in annuities. Financial advisors recommend that their clients make regular deposits into a savings plan, such as an individual retirement account or an IRA. An account into which someone deposits an equal amount of money at equal periods or equal intervals of time is an annuity. There are two categories of annuities. An ordinary annuity occurs when equal deposits are made at the end of each interest period, and annuity due occurs when you make regular deposits at the beginning of the interest period. The money immediately starts earning interest because it's deposited at the beginning of the interest period. The future value of an annuity is the amount of money in the annuity account at the end of a specific period of time. To compute the future value of an ordinary annuity, follow the steps in example 1 using this formula. So you guys, once again, we are looking for tables. We're looking for numbers from a table and then multiplying it by the amount we're putting into the account. Our total interest is our future value that we calculate here minus all of our deposits. So you might have, if you've been depositing for 12 months, you have to take the amount of the deposit, times it by 12, minus it from the future value. So this is probably the most complex part of this process, is figuring out how much you put in. All right, so let's look at Phil. He puts $500 in an ordinary annuity at the end of each quarter. The account earns 6% interest compounded quarterly. What is the future value of the account in 2 years? Or how much interest has it earned? And how much interest has it earned? So the first thing we're going to do is find out how many quarters have gone by in 2 years. So we take 4 quarters in a year, times it by 2 years that have gone by, and we are looking at 8 quarters. The next thing we do is we find the interest rate. The annual interest rate is 6%, and we have we're compounding it quarterly, so we're going to divide by 4. So our quarterly interest rate is 1.5%. Now we hop over to page A12. So let me pull my math book up here. All right, so here we are at A12. Let's get a single view. And we have 8 quarters at 1.5%. So our number is 8.43284. That's where this number comes from. We multiply it by $500 because that's how much we're putting in. And after 2 years or 8 quarters, our amount we have in our account is $4,216.42. So now we need to figure out, without what we're putting in, how much interest have we earned? So we've made, for 8 quarters, we put in $500. So 8 times 500 is 4,000. We're going to minus our amount in our account, minus 4,000 to get the total interest of $216.42. All right, we're going to use this example and do the same calculation. Roy Drennan deposited $5,000 into an ordinary annuity after each quarter for 3 years at 6% interest compounded quarterly. So the first thing that we're going to do is, just like up here, calculate how many periods we encounter. So 3 years compounded quarterly is 3 So our number of periods is 3 years times 4 quarters. So that is 12 periods that we earn interest. And then we take this 6% and we divide it by 4 because it's the 6% is for the year, but we're compounding it quarterly. And we get 1.5%. So now we hop back over to our book. We look at 1.5%, 12, let me pull that number. 12 and 1.5% is 13.04121. So we take our number from our table and we multiply it by what we are. Oh man, that's a lot of money. We're multiplying, putting in she's putting in $5,000 each quarter. That's quite a bit of money. So we do that on our calculator, and I'll do it on mine. 0.4121 times 5,000. Nice. So after 12 quarters, he will have $65,206.05. And that answers A, that's the future value. And then B is this minus so for 12 periods, he put in $5,000, which 12 times 5,000 is 60,000. So $65,206.05 minus the 60,000 is $5,206.05. Just an interest. So we would not say no thank you if somebody just said, here's $5,000. All right, let's calculate the other way. Same problem. Made $500 deposits in an annuity due at the beginning of each quarter in an account earning 6% interest compounded quarterly. What is the future value of the account in 2 years? How much interest will it have earned? So the calculation is the same. For an ordinary annuity, we would make $4,216.42. Our rate is 1.5%, but as a decimal, it is 0.015. So the future value for an annuity due is the ordinary annuity amount times whatever 1 plus your percentage is. So 1 plus 1.5%. So that is 1.015. So $4,216.42 times 1.015 gives us $4,279.67. So if we subtract out our $4,000 that we put in, we see that we've made $279.67 in interest. So a little bit more interest on the annuity due because you get one more compounding period. Okay, we're going to do this, we're going to practice this using the concept check that we just did. So let's take our $65,206.05. We're going to multiply that by 1 plus 1.5%, and just so that you guys can see. So in the calculator, you go 1.5%. 1.5%. Okay, so 1 plus 1.5% equals, and then we times that by $65,206.05. Boom. So we get $66,184, and this rounds to 14 cents. To figure out how much interest, we're going to minus out 12 payments of $5,000, which we remember is, oh, that's, the number's getting all crazy, $60,000. So this is A, it's our future value, and B, our interest is $6,184.14. All right, and that is what our lesson is for today. Take a moment. I'm going to show you the answers. All right, so here's the answers to the practice for 5-8. Let me know if you need help calculating any of it, and y'all have yourself a great day.